good evening, wherever you may be. It's a pleasure to be here with you today. And I'll be taking you in this lesson through the introduction to DevOps and DevOps tools and Azure DevOps as well. So in this lesson, we're going to be looking at one of the most popular DevOps platform, which is Azure DevOps. We'll see what it is, what you can do with the Azure DevOps platform, how to use it for your software development projects, and generally how it is relevant to you as an engineer. We'll see different features and use cases of Azure DevOps and how it all works and how you can implement the whole software development and development lifecycle with it. Also, we'll look at some other open source tools that are relevant to your career as a DevOps engineer. All right, so let's get right into it. My name is Larry Arubulu, and I am a DevOps engineer. I've been in this field for a little over 5 years, fast with multi-cloud platforms, DevOps for DevOps. I have experience with Azure, AWS, and Google Cloud Platform as well. So in today's lesson, I'll be sharing with you my wealth of experience, and I hope you'll learn a thing or two from this. All right, so let's just go right into it. What is Azure DevOps? I'll be sharing my screen, and let me know in the chat if you can see my screen. Just let me know in the chat, and confirm that you can see my screen. All right. So what is Azure DevOps? And as the name suggests, Azure DevOps is a platform, a software as a service platform. It is a software as a service offering which was created basically to be a one-stop shop for implementing all your DevOps processes for your project, and it has come a long way from what it used to be. In the past, it was called Visual Studio Team Services, and that had a bunch of other names before now. All right, but now the term DevOps has been introduced into the name, and now it's called Azure DevOps because now it is more widely accepted, and a lot of projects across the globe uses DevOps principles to deliver software faster and in a more efficient manner. All right. So before we go into Azure DevOps platform, I want us to take a look quickly at DevOps and what DevOps is. Right. I want us to understand, get a grasp of continuous delivery with DevOps and also with Azure, especially with Azure. All right. So again, what is DevOps? And this is the outline of what we are going to be covering in today's lesson: the why, the what, traditional development, software development, workflows that existed over time, and compared to what we have now, the modern way of developing and delivering software products to the market, how continuous delivery works, how DevOps works, and the basic principles of DevOps. Also, we'll be looking at Azure DevOps tools such as the Azure boards, Azure repo, Azure pipeline, test plans, and artifact, and how all of this come together to make a holistic, an awesome ecosystem of tools that will enable and facilitate the delivery, the build and delivery of software to the market in record time. All right, so this is what we are going to be looking at. As you can see on my screen, this is the outline of what we'll be covering in today's lesson. So why don't we just get right to it? So again, the big question is, why DevOps? Why do we need tools to help us enable software development? You see, as DevOps engineer and in the DevOps ecosystem, we need, there's a whole lot of moving parts, so many moving parts. And because we have so many moving parts, we need tools that can provide insight into the holistic way that everything comes together. Tools that provide insights, every step along the way as we go through the journey of developing and delivering software to end users. All right, so we need tools that are secure and traceable, reliable, and easy to use and maintain. as well. So let's quickly, I'm going to compare the traditional approach to delivering software versus the modern approach. You see, in the traditional approach, we used the waterfall method. And this is a method where in which every part of software development is being carried out simultaneously. So this method had its pros, it had its advantages where this could lead to faster delivery to the market because you have the development, testing, and the provision of infrastructure, everything happening simultaneously. In this approach, the drawback with this approach was that if there's ever a point where there's an error or a mistake, or you have to make a correction to your development, you need to revisit everything all over again. So in the traditional approach, which was waterfall approach, there was no clear separation between operations and business, right? Every single part of the software development lifecycle would usually happen concurrently. So yeah, writing the codes, yeah, writing the tests for the codes, yeah, building, developing, provisioning resources simultaneously. And if ever there was an error or we need to revisit or make changes to the application code, usually this will affect the entire application. So when we compare this to the modern way of delivering software, which is there are modern workflows like the agile methodology and the DevOps methodology, which is going to be our focus in today's lesson, right? In the agile methodology, software is built and deployed in small batches, called sprints. So we have it's a time block period called a sprint. This usually lasts between 10 to 14 days, right? And in this time, a new feature is usually built and delivered. A new feature is usually built and delivered. And this method, was effective. Is usually very effective. However, the release times for even agile methodology means you have to wait 10 days, between 10 to 14 days before a new feature is released into the market. However, with the DevOps methodology and modern DevOps principle, it is possible, it is now possible to deliver software features to the market on a daily basis using the DevOps approach. And this is what we are going to be looking at in depth today. Right? This is what we are going to be looking at in depth today. Right? So the highest priority, this is first principle behind the agile methodology. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. However, this is a time block approach, and this would usually take between 10 to 14 days. All right. However, with DevOps, we have something called continuous delivery. And this is continuous delivery is all about creating repeatable and reliable process for delivering software in order to deliver high value software to our end users. So with continuous delivery, we can continuously and reliably deliver software to end users in real time. Right? Donovan Brown, they shared a very interesting perspective on DevOps, and he said DevOps is the union of people, process, and products to enable continuous delivery of values to end users. In a nutshell, the question becomes, what is DevOps, right? And DevOps in itself is a series of cultural practices and principles that enables efficient and effective communication between development teams and operations teams. So DevOps in itself, it's not a single thing. It's a set of principles and practices that we use to deliver software in an efficient manner continuously. All right. And in this, DevOps in itself enables communication, easy communication and collaboration between the development teams and operations teams. This is what DevOps helps us to achieve. This is what we are able to achieve with the power of DevOps. So a lot has been said, and now the big question is, how do we achieve this? How do we achieve this continuous delivery and seamless delivery of software to end users in real time on a daily basis? All right. So DevOps features a series of important blocks, series of number of very important building blocks, and this includes the build phase, the code. This is in the build phase. Oh, excuse me. In the build phase, it all starts with the dev, right? But before we get into actually developing and writing any code, for DevOps to be efficient and for us to have a high and reliable system of delivering software to end users, we first start with something called requirements gathering. Before we write any single line of code, first thing we do is to gather requirement. And this requirement gathering, we have something called a high level definition of the requirements and that needs to be put into consideration for the software to function as expected. All right, we have a series of, this high level description of the project is first of all documented. And in this documentation, we put into consideration every single thing that is required for our software to be built and for the end users to be able to access the software. Everything that the end users need to, every function that needs to go into consideration is first of all documented. And in this documentation, we now go take it a step further to break down the documentation into something called tasks, right? To break this documentation into tasks or tickets, right? This can also be called tickets, and this helps us to achieve, a very efficient workflow, very efficient workflow. And also, with this workflow, we can now go and break down each function and feature into tasks and now assign these tasks to members of the team. So we could have a team that comprises of different roles. We have roles like the developers, software developers, front end, back end developers that write actual codes and application logic, right? So when we have high level requirements, we know from the high level requirement we can determine how many software developers will be required and how long it will take to build our application. So from this, we can break down the high-level requirement into specific tasks and now assign these tasks to different team members wearing different a particular hat within the team. So this would be roles within a team. So we have roles within a team, and then these tasks get assigned to different team members. And this is how we can be sure that we are developing a software and the application code that is going to be written is properly thought out. We have a well thought out process to writing and delivering the application to our end users. All right, this is how we can ensure that the workflow of the project will be seamless, and everybody within the team knows exactly what roles they are to play in achieving the company goals. This is how we ensure that every team member knows what roles they have to play in achieving the company goals. All right. So after we divide the tasks and split the tasks between the team members, we visit our workflows, right? Like I mentioned earlier, there are a number of popular workflows. We've seen the waterfall approach, the waterfall workflow, where every phase of development of software development lifecycle is ongoing at the same time. So in the waterfall approach, we have every phase of development ongoing at the same time. We have the testing, the development, the business, every single part of it, is ongoing at the same time. Also, like I mentioned earlier, we also have the agile and Scrum. Many projects today use one of these approaches for their development. However, with the DevOps approach to software development, we can be sure that we'll have features developed daily. And how can we achieve this? This is the big question. How can we achieve this continuous delivery of features on a daily basis. Depending on the company where you work, any of these approaches might be favored by your organization, depending on where you work, right? But you can advise as a DevOps engineer, it is your duty to share the benefits of using the DevOps approach, which I will be sharing with you shortly on how to deliver software to the market very fast. All right. Also, we have something called a board, a Jira board, where we track the progress of the features and where we have, we record the tickets and the tasks that need to be carried out by each member of the team. So on our Jira boards, on the Azure boards, similar to the Jira board, we record these tasks and we share with the entire team so each team member can keep track and plan on how to execute each of these tasks in real time. All right, so quickly, before I go on to speak in depth about Azure and Azure DevOps, I want to visit how we develop software with the DevOps methodology, how we develop software with the DevOps methodology. All right, so right here on my screen, this is the DevOps software development lifecycle at a glance, right? So you can see different tools and the different phases of the DevOps software development methodology. It starts out with planning, right? So after we've planned, next we would begin to write the code based on the high-level requirement that we have come up with or that the client has shared with us. So we will have the code written based on the high-level and low-level requirement that has been documented and broken down into specific tasks for each member of the team. Next, we'll go into the coding, right? Next, developers will begin to write codes, and after the codes have been written, we'll go into the build phase, and from the build phase, next is the testing phase, where we test the code that has been written to assure that they are quality codes and that they are portable. There are no duplications, code smears, and things like that, and security breaches as well to ensure that the codes are quality codes. And after testing, we'll go on to now deploying the code. So when we've deployed our application, when we've built and we've tested, we'll go on to deploy. Rest assured that our codes are quality and that they are good for deployment. Next, after deploying, we would operate on this code. So by operation, we simply mean that we are going to be having some members within the team manage the code in real time. And while they manage the code, we would also monitor everything that is going on from end to end. So from monitor our application, run health checks, ensure that the applications are live and responding. And off the top, we have so many tools we work with as DevOps engineers. So we are required to have a solid grasp of so many different tools. I'm going to be sharing, speaking on each of these two quickly. But before I go on, I'm just going to take some minutes to explain the DevOps tools that we use in the open source world. And next, after I do that, I'm going to speak on Azure DevOps tools and how Azure has made life much easier for every DevOps engineer by coming up with a software as a service called Azure DevOps. All right. So quickly, now this is how DevOps is being carried out. Right here on my screen, I'm sure you can see my screen. I have a diagrammatic representation of the DevOps process end-to-end, of the DevOps end-to-end process. All right. And DevOps as a concept, as a practice, it's all about automation. It's all about automating the delivery of software to end users in real time. It's all about automating that process from the process of writing the codes to the end where users can access the application. And in DevOps, there's a popular saying that DevOps is comprises of 7 pillars, and these pillars are continuous development, continuous integration, continuous testing, continuous deployment, continuous delivery, continuous monitoring, and continuous security. Now, this might sound like a lot, but as we go through, you realize that these are just principles, and that once you get a solid grasp of these principles, you would be able to function and understand why we require so many tools as DevOps engineers. So, uh, please let me know in the chat if you can see my screen. You can still see what I'm sharing. Please just leave a comment in the chat and let me know you can see what I'm sharing on my screen. So quickly, so usually in the real world, we will have developers writing code. So we have developers writing codes every day and committing these codes to something called a source code repository. All right, I'm going to be going through every single item I've put in the diagram on my screen. So in real time, we have developers, right, committing codes, and these developers would usually be in different, they could be in different parts of the world. We have developers in different parts of the world writing codes, and this code that developers would usually write would be it could be in different languages. For instance, we could use, say, Node.js or React.js for front-end code, and we could use Java for our backend, and we could use Python to manage write our database logic. All right, and when developers write this code, there has to be a way to monitor and keep track of the codes that developers are writing. Also, there also has to be a way for us to collaborate, for developers to collaborate in real time. So say we have 4 front-end developers working on an application code, and each of these developers are writing code on their local machine. There has to be a way for developer A to know what developer B has written, and so that there's easy collaboration. For this, we use a tool called a source code manager, all right, to manage the source code. So the codes that developers write, this makes up the source code of our application, makes up the front end source code and the back end source code, which is the application logic. And developers write and commit this code to something called a source code manager in real time. On my screen here, I've listed a number of source code managers, right? For source code managers, we have we have GitHub, Bitbucket, GitLab, and there's quite a number of source code managers. But in essence, all source code managers help to achieve similar functions. Our source code managers help us to keep track of the codes that developers are writing daily, because developers will write code every day and commit this code to a repository. This repository could be local on their machines, or it could be a centralized repository, or we could have a source code manager, such as GitHub, where developers would commit this code, and this usually will help with collaboration. We also have Azure repos, which is very similar to GitHub and GitLab, right? Very similar in how they function. The principle behind using a source code manager, is to ensure smooth communication and collaboration between developing teams and developers as well, and also to keep track of our source code so we don't lose it. What happens if the developer's computer crashes? We have things like incidents like that, where a junior developer writing a code locally on his machine, and then machine crashes, and then he loses all the progress that he has made so far on the code. So we have source code managers to help deal with this. So with source code managers, usually source code managers come uses a versioning tool such as Git. Git is the most popular versioning tool, and with source code managers equipped with Git, we are able to keep track of the versions of software that developers write. And this is how we use source code manager. So developers will usually commit source code, test cases, and build scripts to the source code managers, right? As we go on, I'm going to speak more on build scripts and what build scripts are. I'm going to be speaking more on build scripts and what build scripts are. All right. So after, follow along with me closely. So I'm taking us again. We're looking at DevOps end-to-end life cycle. We're looking at DevOps end-to-end life cycle, and by understanding DevOps end-to-end life cycle, we are going to be able to get a good grasp, a solid grasp of what DevOps is, how it works, and how we can implement it to improve delivery time on our projects moving forward. All right. So a quick recap. I said there are 7 phases. Yeah, there are 7 pillars of DevOps, and the first pillar is the continuous development, and this involves developers continuously writing codes and committing these codes to a source code manager where every developer can contribute and collaborate and give feedback on the codes that is being written. All right, every developer collaborates on a source code manager, and the version of the code is being versioned using a versioning tool such as Git. There are other versioning tools, but the most widely used versioning tool in the market today is Git. We use Git for versioning. All right. So moving on. So next, after developers have written codes and committed these codes to a source code manager such as Git, the very next thing to do or to take note of on the DevOps methodology is the continuous integration. This is the very next pillar. You see, because we have a whole lot of tools, we have so many tools that we need to implement in our pipeline to ensure delivery of quality software to end users in real time and very fast. We are required to work with so many tools, and so we need to continuously integrate each of these tools into our process. So this is the concept behind continuous integration. We are continuously integrating each of these tools, as you can see on my screen, right? We are going to be continuously integrating each of these tools in real time. We're going to be configuring all of these tools and ensuring that they are all working together in real time and in a automated manner. So we are all about automating the use of all of these tools, as you can see on my screen, from Git to Docker to each of the tools you can see on my screen, which I'm going to be covering as we proceed. All right, so we're going to be integrating each of these tools in real time. So this is the concept behind continuous integration, ensuring that each of these tools are configured correctly and working together to achieve the desired results and goals of our organization. So this is what we mean by continuously integrating with DevOps, continuously integrating with DevOps. So next, after we configure, which we are going to look at shortly, how to configure, configuring each of these tools and how they all come together. We're going to look at this very shortly. But the very next thing we need to do is to test. After developers have written code and committed to a source code manager, it is important and very necessary. This is for security reasons, to ensure that the codes that have been written by developers are quality and that these codes have no security breaches, that these codes have been written following best practices, standard guidelines for best practices when it comes to code development. We have to ensure that best practices are being adhered to. As DevOps engineers, it is your duty to ensure that best practices are followed when it comes to code writing. So we have to ensure that the codes are portable and that developers also write unit test cases, and that we have a good enough code coverage. By code coverage, I mean that we have unit test cases written to ensure that the codes perform exactly as expected. There are no surprises. So developers are required to write unit test cases to ensure that the codes function as expected. So developers are required to write a unit test case for every line of code. This is called code coverage. And for this, we will be integrating a tool to test the code that developers have written. We'll be integrating a tool. And one of the very popular tools used for code coverage, to test code coverage and to run unit tests is called SonarQube. And this will be our second tool today that we're going to be looking at. Our third tool, right? And tell me in the chat how many tools you can remember. I know I've spoken about Azure Boards and Jira, which is used for documenting and high-level planning of our project. I've also spoken about Git and GitHub as a source code manager and versioning tool. So the next tool we're going to be looking at is a code quality tool, which is SonarQube. So SonarQube Nexus, SonarQube Nexus. SonarQube is the name of the tool, and the company that owns this tool is called SonarType, right? So the name of the tool itself is called SonarQube, and SonarQube is a preferred tool for testing. We also have SonarQube is open source, so it is free. It is free to use, and it comes at no cost. Basically, that's what it means. It is free and it is contributed to by the open source community, maintained and contributed to by the open source community, and it's free for us to use. All right. With Azure DevOps, we have Azure Test. Right, with the Azure DevOps suite, we have a tool called Azure Test, which is very similar, and the Azure tool for testing code and code coverage. But with SonarQube, we are able to test and set quality gates. Quality gates are rules that we use to determine how good our software quality is, how good the code that has been written by developers is. So this is called SonarQube Nexus. All right, this is the tool that we use. So within SonarQube, we're going to create something called a quality gate. And with the quality gates, we'll set rules to say that, well, we want 90% code coverage. That means if the developers have written 10,000 lines of code, we want at least 9,000 lines of test cases to ensure that each line is functioning and gives the expected results when the code is being run. So this is how we test the code to ensure that the developers write the test cases that are required to ensure the code functions as expected. Also, SonarQube will test the portability of the code and will also check if the codes are human readable, whether or not developers have commented the code as appropriately, whether or not the code follow best practices. With SonarQube tool, we can test this. All right, and so we'll integrate SonarQube into our development process. So we usually would integrate SonarQube for code quality analysis. All right. So next, after we ensure that testing. So as DevOps engineer, in the entire workflow, so as DevOps engineer, basically our work begins when the code has been written. As a DevOps engineer, we would plan with the team. We would attend meetings with the team to plan and share insights. We would meet and share insight on and give recommendation on how the software development lifecycle should go. We'll give recommendations. But a day in the life of a DevOps engineer begins with reviewing, and usually you start by checking your mails to see what codes the developers have written and have committed to the repository. So as a DevOps engineer, your work begins when the code has been written. DevOps engineers are usually, in most cases, not required to write code. We write scripts, but we're not usually required to write codes. Your job as a DevOps engineer begins when the code has been written and committed to a source code repository, source code manager, or a repo like GitHub or Bitbucket. That's where your job begins. As a DevOps engineer, it is your job to come up with a source code management strategy or a Git branching strategy is what we call it, right? So you are required to share or give recommendations on the strategy and how developers commit their codes. An example would be in your organization, like in my organization, I require developers are required to commit their codes to a development branch. So we would usually maintain a minimum of 3 branches. We maintain a minimum of 3 branches. Say we have the development branch, a testing branch, and a production branch, which is usually live in production. So we developers would have a strategy whereby developers would create a feature branch for any new feature they're working on, and would create a pull request to merge this feature. And upon review of this pull request, the codes can now be merged. And when the codes get merged, usually into the development branch, next would be the testing, right? So we'll take a copy of this merge code. After reviewing it, merge it into a testing branch, and then run some further tests on the codes before a pull request is then created and the codes are being sent to production, which is usually live. You see, as DevOps engineers, you are going to be managing applications in real time, applications that are live and being accessed by end users. As a result, you have to ensure that you have a solid branching strategy when it comes to managing source code, so that developers don't commit a code directly to your production or your main or production branch that is live, that breaks production, and then you have downtime. Our goal as DevOps engineer is simple, and this is to ensure that we have applications running 24/7, and that our applications have zero downtime. Our applications are accessible to users equally at the same speed to users across the globe in different regions of the world. We ensure that applications are portable, fast, easily accessible, without downtime and without lag. This is your main duty as a DevOps engineer. So, and this is why we come up with branching strategies to ensure that developers don't commit code directly to the main branch, which can break production and lead to downtime. All right, so this is the main job of a DevOps engineer. Our job is to automate the entire process. I'll be with you in a minute. Our job is to ensure the entire process from end to end and reduce human interference with the process of software development as much as possible. Ensure that the codes that are written are quality, and that we don't break what is already in production. We don't break what is already in production. Okay, so moving on to the next item, to the next phase of our development, which is the testing. So after we've tested the code that has been written by developers, next thing we need to do is to build the code. So now we've tested that the code is good quality. Next, we want to build the code, and by building, we mean that from the source code that developers have written, we want to create an executable script, an executable file that can be executed by the computer, because the computer would need to run an executable script for our application to run. So by building the code, we are creating an executable file for the computer, for our servers, basically. So we are going to be creating an executable file for our servers to run. And the tool we use to, depending on the language in which the code has been written, the build tool would vary. So for instance, if the code was written in Java, we would use a build tool called Maven. Maven is the build tool we use for Java for Java applications. We use a build tool called Maven. And with Maven, we can clean the package. We can also run unit tests within Maven to once again test the application, to carry out some further testing on the build artifact, on the build script, to ensure that it functions. Now that the script has been built, it works as expected. So we run some unit tests, JUnit test, regression test, and there's a number of tests we usually carry out on the executable file to ensure that everything is in order, and that the file functions as we expect it to. All right. Also, we will integrate this build tool within our process. We'll also integrate this build tool. So for Java applications, we use a build tool called Maven. We also use Gradle. You can see on my screen, Gradle is a tool we also use for Java applications. All right. For Node.js applications and JavaScript application, we use Node Package Manager as the build tool. So each programming language has its build tool. For Python, we have py builder, and the list goes on and on. For .NET application, for Microsoft .NET applications, we have Nuggets, right? This is build tool for Microsoft applications, for .NET applications. All right. And so we'd usually would integrate this build tool into our system as well. We'd integrate this build tool into our system as well. And at the end of the build, we'd usually have a build artifact, which is an executable script that the computer can run. That the computer can run. All right, and we can deploy to our servers. But next, like I said, as DevOps engineer, it is our job to ensure that our codes, so we have zero downtime. And how do we ensure a zero downtime environment in our build environment? How do we ensure that we have zero downtime? One thing we can do to ensure we have zero downtime is to always make an habit of backing up our build artifact and always creating backups for our work. So when we one thing our source code manager does for us is that it gives a backup. So we have a copy of the source code on the source code manager. The developer has a copy of it on his local machine, and we also have a copy of the source code on our source code manager. And this way, we can be sure that we do not at any point lose our source code. And then as we move further down the development process, we've tested the code, we've created a build artifact, which is an executable script that can be run on our computers, on our servers as well. It is important that we back up the build artifact so that at any point we do not lose our build artifact. So we create a backup, and usually we'll store this backup. We'll back up this artifact in an artifactory, something called an artifactory. And examples of an artifactory, we have artifactories like tools like Nexus. So Nexus is an artifactory. We would usually use Nexus to store a copy of our build artifact. We also have tools like JFrog. We have tools like Amazon ECR. We have ECR. So we have a number of artifactories that we can use as a backup store, so that at any point we do not lose artifacts. We do not lose our artifacts. So if our build server goes down, we can always recall a backup from our artifactory. And so this is a very, very key step. This is a very key step in our development process. But before, as we go on, now we've mentioned at least about 5 or 7 tools. So now the number of tools we need to work with on a daily basis, begins to increase. We see that the number of tools that we are required to work with is increasing at an alarming rate. And how do we manage all of these tools together? So we have to manage our source code, we have to manage our build server, we have to manage at factory, we have to manage our quality control, a quality analysis server, we have to manage SonarQube, Git, GitHub, Maven, build tool, we have to manage Nexus. Now, at this point, it becomes important to find a tool that with which we can manage all of this. And we have so many tools in the DevOps space to manage our pipeline. And one of these tools is Jenkins. All right, one of the tools we use to manage our pipeline is Jenkins. One of the tools we use to manage the pipeline is Jenkins. All right, so with Jenkins, we can now bring together. Sorry. Okay. With Jenkins, we can now bring together all of these tools into our pipeline. So this is Jenkins serves as our CI/CD tool, and so this is the tool that is going to enable us run our pipeline from end to end. So we also have Azure pipeline as well. So with Azure pipeline, we can also integrate all the required steps for our pipeline to function effectively. We can integrate all the required steps. So one important thing that Jenkins does for us, also Jenkins is an open source tool, so this means it is free to use and developed by the community. One important thing that Jenkins does for us is that with Jenkins, we can now integrate each of these tools that we've mentioned. So Jenkins is going to help us achieve continuous integration with GitHub, which is our source code manager. Jenkins also help us achieve continuous integration with our build tool. Jenkins also help us achieve continuous integration with our quality control tool, which is SonarQube, and as well as our Artifactory. Also, Jenkins would ensure that every tool we need for the deployment is integrated into our pipeline. So Jenkins is our preferred tool for continuous integration. So we use Jenkins to integrate each of these in real time. So Jenkins is going to be configured to work with Git. It's going to be configured to work with each of these tools that we have mentioned. All right, Jenkins is going to be configured with each of these tools, and this is how we can achieve continuous integration using a tool called Jenkins. But the power of Jenkins doesn't stop there. Jenkins is a very powerful tool, and the power of Jenkins goes beyond continuous integration. It also helps us to achieve all the remaining 4 pillars of of DevOps. It helps us to achieve the remaining 4 pillars. It helps us to achieve continuous deployment, continuous delivery, continuous monitoring, as well as continuous security, which we're going to be looking at as we proceed. All right. So next, after we have built our artifact and backed up our artifact to the Artifactory, the next thing we want to do is to deploy our artifact into our application servers, right? So after we build our artifact, next we want to deploy our artifact into application servers from which we can now allow end users traffic to access securely. All right, we can now channel end users traffic to access our application on the application servers. Usually, applications in the past, these artifacts will be deployed into application servers such as Tomcat servers and JBoss, such as Tomcat servers, which are web servers for Java applications and for other types of programming applications written in other programming language. We have other similar application servers such as Vercel for Node.js. We can deploy application into Vercel servers. However, in real time, we are going to have more than one application servers. The reason, again, is because, for instance, see, if we have just one application server, say we are deploying an application for uh, for Azure Nigerian community. We're deploying an application for Azure Nigerian community, and it's a web application, and we've written the code and created the executable scripts and backed it up to Artifactory. And now we deploy this web application into a single application server. So deployed into a single application server, and then and we don't have this. We take out these guys here, right? We have just one single application server for application. Now the question is, what happens if this application server is down? So this application is hosted in an availability zone in a region in the United States. It could be hosted anywhere in the world. And say we have a single application server, and this application server goes down. What happens then? That means our entire website, our entire web application is going to be down. Say there's a natural disaster in this region, and then the application server, or the facility hosting this application is down. See, there's a tornado and this is down. That means our entire application is going to be down. And again, this is what we prevent, as this is what we work to prevent as DevOps engineer. We're ensuring that there is no downtime on our application. If this was Twitter, imagine we're deploying for a critical application like a fintech application or a healthcare application, right? And say your GT Bank application or any other banking application is what we are deploying. And then there is downtime and people cannot access their bank balance for, say, 30 minutes or an hour. This could lead to serious consequence for our clients. And we avoid this at every cost. So this is why we deploy to multiple application servers. So we have the multiple application servers deployed in different regions, availability zones, in different regions across the globe, so that if the app server in one region is down by a natural disaster, it's the other application servers are still going to be accessible, and end users traffic can be automatically routed and balanced between these application servers, so that end users do not suffer downtime. The applications don't suffer downtime, and end users can always access applications in real time. This is why we deploy to multiple application servers. All right, but in real time, looking at this in real time, so this right here is one way to deploy applications in real time using application server. However, in the modern world, yes, .NET and .C, etc. So the build tool for applications written in Microsoft languages such as .NET is Nugget, right? There's a build tool called Nugget for Microsoft applications. It's Nugget. All right. So with the advent of, so to solve this problem in real time, right? We deploy applications into something called pods. All right, and this would take me to the next tool. So right here, we have a tool called we have something called containerization in the DevOps world. So everything we've spoken about so far is based on virtualization. And as we all know, so we have there's quite a number of tools we work with as DevOps engineers, and the most important thing we need to grasp is the underlying principle and why we use each of these tools. Why each of these tools are important. The most important thing you need to grasp is why each of these tools are important. For all the many tools I've mentioned, basically when you have a solid grasp of why and the principle behind why we use each of these tools and why each of these tools are important, then you can now decide with within your team and within your organization how many of these tools is important to achieve your company goals, right? All these tools, not all these tools are used by every single organization, but as a DevOps engineer, it is important to have a solid grasp of the principles behind the use of each of these tools. And when you have the solid grasp, you can now decide, based on your proficiency, which skill, which tool you require to achieve your organizational goals and achieve your company goals. All right. I'm going to take all of these questions one after the other, but just so that you follow along, I'm just going to quickly speak about the deployment part. All right. So far we've seen how to the tools that are required to deploy applications to end users in one way using application servers. So, but in the modern world, there are some, there's been some improvements to this on how we deploy applications. Let me tell you something. So, in real time, you're going to be creating multiple multiple servers. Like I mean, multiple servers in the cloud. Yes, having a solid grasp of the basics is enough to get you going. Having a solid grasp of the basic principles would definitely get you going in the DevOps space. And when you understand the tool and why you are using it, it will become much easier for you to understand, how the tool works. When you understand the basic principles of why you need this tool. For instance, you understand that you need to test your codes to see how how quality of how the code quality is, or what the quality of the code is. And when you understand that low quality codes could be a security breach, it could give hackers access to your application because there's a security breach as a result of low quality codes that were written. Then you understand, oh well, then I need to use this tool because of this particular reason. And I tell you, each of these tools are quite easy to understand. When you start working with it, so it becomes something that you retain in your muscle memory. It becomes a part of you, and once it becomes a part of you, it's something you use every day. It becomes a part of your tool stack. You become familiar with it. Integrating each of these tools and working with each of these tools is as easy as installing a software on your computer. I'll say that again. Working with each of these tools you see right here on my screen is as easy as installing this software on your computer, and you're good to go. As soon as you can install the tools and understand what they are and what function they serve in your development process, you're good to go. You are good to start working with them. All right. Well, I think this answers your question as well. As soon as you understand the tools that you need to deliver the software and how they work and how they function and what need is it to you in your development process, you are good to begin your developing and deploying apps as well. All right. So again, like I mentioned earlier, for when it comes to deployment in the modern world, there's a concept called containerization. And what containerization basically means is that instead of as opposed to shipping out virtualized software into virtualized computers in the cloud, virtual computers in the cloud, we deploy our application into something called a container. What do I mean by virtualization and containerization? So you see, with cloud computing, we have something called virtualization. Servers on the cloud are examples of virtual computers. So this is a runtime instance of a computer on the cloud. So on your local machine, the same way you have your local machine, you have your computer, you have the hardware, you have the storage, you have the operating system physically, on your computer, running on your computer and making your computer work. You have all the hardware and software components of the computer. We have this on the cloud as virtual computers. So we have virtual computers, and these virtual computers also have operating systems, storage, and every capability that physical computers have. So this is virtualization technology. And this is the basis of, this is how we cloud computing works. So this is how we have computers on the cloud, and we call them servers, EC2 instances. We call them virtual machines, Azure virtual machines, right? We have Google Compute, right? We have virtual Google Compute machines as well, right? We have these machines. These are virtual computers. And when it comes to DevOps, each of these, like your code quality, again, to avoid a single point of failure, we have each of these points right here hosted on a single server. So we would usually have code quality, a server running our code quality analysis integrated with Jenkins. We will have our build server integrated with Jenkins running our builds. We'll have our Artifactory, server that is running our Artifactory, and we'll have multiple servers. And if you take a quick count, at this point, we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. We could have as many as 10 servers running at a single time. And this can lead to high operational cost for our organization. So to reduce this operational cost, there has been improvement in how software has been developed. Imagine we want to deploy our application to 10 availability zones in different regions of the world. We'll have as many as 10 servers. We'll have to provision as many as 10 servers, and this will lead to high operational cost. All right, this will lead to high operational cost. So for when it comes to deployment, this is a second diagram, right? And right here, when it comes to deployment it's basically the same thing with some changes. All right, instead of deploying our applications, our artifacts directly into our application servers, we use something called containerization technology. And in containerization technology, this just means that we ship our application as a container. A container is a runtime instance of our application. Now, let me ask you this question. There's this popular saying, when I don't know if you've experienced or you've come across a situation whereby an application is working on your local machine, and then you share the application with a co-developer or a co-worker, and that application breaks on their own computer. So the application works perfectly on my computer, and then I ship it out. I send it to a co-worker or a colleague or to the QA team to test. And then when they launch the application on their machine, it doesn't work. Sometimes it could be because you've configured some environmental variables locally on your machine, and those environmental variables, which is not best practice to share publicly, right, could make the application break on a second machine. This is a possibility of this happening. All right. However, it is possible to package your application with the operating system that it requires to work with every single dependency that the application needs to run on every machine. And we use a technology called container technology to package applications, and every dependency that the application requires to work. I mean, every single dependency, including the operating system that the application requires to work, and in the specific version that it has been built in. So it is possible to package all of this into a container. So instead of shipping the artifact out into our application server, we would package the application artifact along with the operating system and every dependency that artifact requires to run on a given machine. And we'll usually build something called an image. So we build an image using a tool called Docker. So Docker is the most widespread containerization tool. So with Docker, instead we can, with Docker, we can pull our Docker, we can pull our artifact from the Artifactory into our pipeline and build a Docker image. We'll build a Docker image that can run in a container. So a container is a runtime instance of an image, right? So that's what a container is. So Docker is a tool we use for containerization. And with Docker, we would deploy our application as images. So we can serve our application package with every dependency that it requires to work on every single machine. So usually when you're accessing an application on your phone, that application typically, if it usually will have been deployed with everything you need. So again, most of our build and our build servers are usually Linux machines. We also work on Windows machines and we could also work on iOS machine. But the most popular and predominant machine in the DevOps space and in the software development and deployment space is Linux machines. And so you build your application, it is working on a Linux machine. And now your end users are using an Android OS, or they use Mac OS, or they use Windows OS. And then how can you be sure that these applications will work the same way, with the same features, functioning in the same way on every single machine? This is where containerization and Docker comes into play. Docker is a way to ship your entire computer. If you're a developer and you've built a wonderful application, Docker is similar to shipping your entire system, giving it to every single end user that is using your application. However, Docker does this using containerization technology. And so Docker is a tool that helps us to containerize application. As you go further in your DevOps journey, you become more familiar with this tool. And again, I assure you, these tools are as easy as learning how to install the software. Docker can be installed locally on your machine. You can install Docker on iOS, you can install Docker on your Windows machine and just play around the software for a start, right? You can install Docker desktop on your desktop and work on it and play around the interface and get familiar with it. All right. So these are tools that are as easy as installing every other software on your computer. All right. So when we package our applications from the artifact, we build something called an image. We build something called an image, a Docker image. All right. We build something called a Docker image from our artifact, and this Docker image, again, to prevent a single point of failure, we would back up this image to an image repository, right? We could also use Nexus for this backup, but usually there are image repositories in the cloud that come with extra features, like they can scan the image for vulnerabilities and give you some extra security features as well. So right, and also even this image repository would give you access to industry standard and approved images for your build. All right, to build your Docker images, and you can have these images as part of your pipeline. So we'll back up these images to Docker Hub, and when we backed up our images to Docker Hub, now we have an image that contains everything our application requires to run. We have everything packaged into an image, and this image can be run inside a container. So when I say a container is basically a lightweight version of a computer. It's basically a lightweight version of a computer. So when you have multiple containers, they share resources, they share the operating system, which usually takes up about 90% of your system space, of your memory. So the operating system takes up a huge chunk of your compute of the space on your server, right? So, but when you share this inside within containers, you can have lightweight versions that share resources at lower level, and you can focus on the memory usage on what truly matters, which is your application and application dependencies. All right. So usually when we have container images, and the images are ready to be deployed into containers, into a container, and then we want to deploy this. We want to have multiple containers, or want to have multiple instances, runtime instances of application. It's possible to have the images deployed into so many containers. But what happens when you have as many as 20 containers, and and then you have as many as 10 containers, and then you have to manage all of these containers in real time. So this brings us to our next tool. So we introduce a tool called Kubernetes, and again, this tool is, when you understand why we need it to, you understand, the use becomes easy to grasp. All right. Kubernetes is a tool that we use for container orchestration. And so there are other tools that are used for container orchestration. We have Docker Swarm as well, but Kubernetes is the most advanced and the most widespread tool for container orchestration. And by container orchestration, I simply mean managing multiple containers. So when you have so many containers to manage, Kubernetes will come in to help you manage each of these containers. And Kubernetes does this by creating pods. So within Kubernetes, we can create pods, and by pods, these are just this is the smallest units within within Kubernetes. So pods is just a small unit. Think of pods as a shell. This as a shell basically. Think of pods as a as a mm, as a as a bucket, or as just as a maybe a flask, right? Just something you used to put something inside. Just think of pods like that. And these pods will contain uh, your containers. They'll contain, and then your applications will live inside this pod. So with Kubernetes, you can deploy multiple pods. All right, you can deploy multiple pods, and this way, this can all be on a single server. You can have this, on a single server or just two servers. So instead of deploying your application into 10 servers as well at once, you can have a single master server, that serves as your control plane, and then you have worker servers, like two worker servers, which or three, as many as much as you need, right? Depending on how large your application is and how many availability zones you want your applications deployed to. So you can have a single node, a single server deployed in each availability zone, and within each of those servers, you can now deploy multiple pods. All right, and one thing that Kubernetes and Docker, shines at is when it comes to micro service architecture. So imagine that you have an application that you want to deploy, say the home page as a single application. You want the login page to stand as a single. You want to deploy it separately. You want to deploy the register page as a separate page. You want to deploy maybe it's an e-commerce application, and you want to deploy, or let's stick to a banking or a fintech application, right? You want the login page to be a standalone application, to be deployed, as a standalone. You want your register page. You want each of the different items on your navigation bar to be deployed as a single standalone deployment. All right, and for this, there are many reasons why you want to do this, but one important reason is why organizations use microservice architecture is that usually when you open a fintech app, sometimes when there's a downtime and you have a microservice architecture, the downtime doesn't affect the entire application, so your entire application doesn't go down. So imagine that your login page is down, right? Users cannot log in, but the registration page is still up because it is deployed separately. In a monolithic, as opposed to a monolithic architecture, where when one thing goes down, every single thing goes down. When you have a microservice architecture, when one feature goes down, say your login goes down, people can still register. In a fintech application, people can still access their dashboard. They can still view their balance. They can still transfer funds, even if the register page is down and you cannot register new users at the moment. So these are several. These are several. This is the importance of a microservice architecture. And then when you have multiple pods, so you can have your login page. This could be your login right here, deployed into a single pod and then register. And then you could have the cart, your dashboard, deployed the dashboard deployed as a standalone deployment, and so on. All right. So this is why we use this tool. It saves cost in that we do not have to provision so many servers. It reduces operational costs by a very large margin, and this is an advantage to every organization. That's why as a DevOps engineer, every organization wants a DevOps engineer that understands container orchestration using tools like Kubernetes and Docker, and a DevOps engineer that can and create a pipeline and automate all of these processes. All right. So with Jenkins, we can automate both the continuous integration and development of applications. We can integrate this. And one final thing, all right, one final thing before we go, as we go on, is continuous monitoring. Now, we have deployed our application into application servers or into pods using Kubernetes. It is important to monitor the health of our application in real time. It's important to monitor our application health in real time. We want to see we want to know and get notification and alerts if there are downtimes, if application is responding, if users are able to access application in real time. We want to be able to monitor the log files, and visualize the logs that are application logs in real time. We want to be able to monitor and visualize the application logs, the feedback we get in real time. And for this, we use monitoring tools, and we have a number of monitoring tools that we use in the dev space. We have Prometheus, which basically collects all the logs across our application. It collects all the logs, and then it's possible to visualize these logs using a tool called Grafana. We can visualize the logs from Prometheus and have a dashboard that tells us the health of our application at every single time. Also, there are tools like New Relic that pings our application, at intervals to let us know if our application is down or alive, and sends alerts to us via email. And all of these can be configured and integrated into using Jenkins, into our pipeline using Jenkins. All right, we can configure all of this into our pipeline using Jenkins in real time, and also configure email alerts that would send feedback to the support team, or eventually there's a downtime, or we need to quickly visit or pay attention to our application. We need to go in and look at something, or we've gotten a feedback from our end users, and then we need to access this in, go back and review and make correction to our code or change it in real time. So we configure alerts as well into our pipeline. But before I go on, there's something vital, there's something very important that I missed. So I need to go over. So in real time, end users are not going to be accessing application directly. They're not going to be accessing application directly for security reasons. We don't want end users, logging and accessing our application servers. This could lead to a security breach. For this reason, we use a tool called we use an application load balancer for this purpose. I'm just going to introduce an application load balancer right here. And for this application load balancer, we could use a tool called Nginx. Nginx is a very popular tool. It's a very popular tool that serves as application load balancer. So we use this to control end user to route end user traffic. We use this to route, so if I can type correctly, we use this to route end user traffic to our application. We use this to route end user traffic to our application in real time. So Nginx is a tool we can configure to take in end user traffic and allow end user access our application in real time. So right now, this is an overview of the DevOps end-to-end tooling process. This is DevOps end-to-end. Every single tool we've mentioned here makes up the DevOps end-to-end lifecycle, and we automate this using the critical tool right here, called a CI/CD tool, such as Azure Pipeline, Jenkins, AWS Code Suite as well, Code Pipeline. Also, there are similar tools like Circle CI, Travis CI. This all helps us to achieve end-to-end automation of our pipeline. And the way this works is the way Jenkins and each of these tools work is we configure something called a webhook, right? On our CI/CD, we configure something called a webhook. We could use a webhook, or we could either configure a cron job. We could use a cron job for this that would check at intervals to see if any change has been made to the source code, or we could use a webhook as well. We could use a webhook. We could also use something called a pull SCM, right? We could use pull SCM. Each of these will be configured in CI/CD tools such as Jenkins, AWS Code Pipeline, and we use this would trigger Jenkins or our automation tool to check if there's been any change to our pipeline. And the moment we need the automation tool, a CI/CD automation tool, notices any change in the pipeline, it will automatically run the code through each of these tools. And this is the beauty and the power of continuous integration. It's going to continuously run this check and run the code that has been committed through each of these steps, one after the other. The moment a developer commits a code or makes any change based on the triggers we set for automation tool, this is all going to be automated at the click of the button. This is all going to be automated, and up to the point of where we get alerts. So we just get alerts, that a change code has been committed, and if there's any point at which we need to come in and look at the result of the code that has been committed. If there's any break, we just need to come in and monitor and check it. And when we configure this properly, we get a dashboard where we can visualize these processes on the dashboard. We get this visualized using tools like Grafana and Prometheus, which will track the logs from each of these tools and give us a visual dashboard. So this is the DevOps end-to-end lifecycle. This is DevOps end-to-end lifecycle. Ansible. Oh, that's a very good question. So Ansible is a tool we use for configuration management. So Ansible as well is a automation tool. Let me show you where Ansible comes in. All right, I intentionally left that out so we don't complete. But yeah, this is where Ansible comes in. All right, Ansible is as an automation tool as well, and Ansible comes in here. So Ansible is a tool we use for configuration management, and by configuration management, what I mean is that, so usually, sorry, let me just okay, this is good. So Ansible would come in right here. So we use Ansible for configuration management. Use Ansible for configuration management. So usually in real time, it is possible that we are working with uh, you know, different cloud service providers. Like we could be working in multiple service providers such as AWS, Azure. We could be deploying our code in virtual machine on the cloud, on-prem, and we would require roles for this for each user. So you have a user, an Azure user that is accessing your Azure DevOps to deploy code for you, and these users has to be managed, right? We need to provision resources as well. So Ansible comes in when it comes to configuration management, managing users, and automating this configuration. So we use something called Ansible playbooks, right, to automate infrastructure provision. So we want to provision infrastructure or on say Ansible can provision infrastructure on a 100 then 100 is right. It depends on how big they are. Say on 10 CSPs, we could provision. We could want to provision infrastructure on 10 CSPs. We could want to provision do something like this, right? We want to provision infrastructure on 10, say 10 on the number of cloud service providers at a single time, right? This is where Ansible would come in. Ansible is a very powerful tool, and not just Ansible. There are similar tools to Ansible, such as Chef and Puppet. All right, these are powerful tools. So Ansible basically helps with configuration management and helps us have a consistent configuration across all of these servers across different cloud service providers. Also, it helps with something called infrastructure as a code. So usually we would write something called a Jenkins script or a CI/CD script. So we have something called a script right here. Right? So we have something called a CI/CD script. We have a CI/CD script right here, and in this script, this is the script that will automate that where we specify the commands that and the instructions for the CI/CD tool to use in automating our pipeline. So we write a script like this. Similarly, we have something called a automation script, right? Our entire infrastructure can be written as a script. And the reason why we do this is to make sure that there are no mistakes. So say we want to do this over, want to provision 10 infrastructures on 3 different cloud service providers. So we want to provision something like, want to provision 10 infrastructures, right? Want to provision 10 infrastructures, right, on 3 different cloud service providers. And then, the manual way to do this would be to go to my Azure and then create a virtual machine and then begin to specify the configuration and specify how many CPUs I want this virtual machine to have. I want to have dual core. I want to have 4 core, 4 CPUs. I want 100 gigabyte of storage, and then I'll go on and specify I want this particular operating system running on my virtual machine. I want Linux, this distribution of Linux or any other software. This will be the manual way to do this, right? But with infrastructure as a code, which is another a principle, a practice in DevOps, it makes our provisioning easy because we specify everything we want in a single file, usually a YAML file or a JSON file. We specify everything that we want to go into our infrastructure based on the high-level requirements. We can specify all of this into a YAML file, and and by executing this YAML file, our infrastructure would automatically get provisioned, and every single thing we want to go into infrastructure, the number of infrastructures, the number of CPUs, every detail is configured, is written, is represented in the it's called in the logical resource, right? So Ansible basically manages a logical resource, and for every logical resource, a physical resource is going to be created. So in Ansible, we create something called a playbook. This playbook is going to contain the YAML files, and every logical resource is going to be written out in a playbook. And by executing these playbooks, we are going to have all of these provisions automatically. And again, like I said, DevOps is all about end-to-end automation, reducing human involvement in the build and delivery of quality software to end users. So this is what DevOps is all about. Ansible helps us orchestrate all of this complex workflow using infrastructure as a code practice, right? It helps us to manage configuration of our users and people and us on our servers across different cloud service providers. Ansible is a very powerful tool, and this helps us to ensure that our processes are standardized and reproducible. So if you have your entire infrastructure written into a playbook, you can easily reproduce this. If you can produce this time and time again, right? You can reproduce it easily, and this is where Ansible really helps us to make our work easier. So with cloud automation, Ansible helps us to work with multiple cloud service providers at simultaneously, right? It manages the configuration of each cloud service provider, and this can help us to scale our infrastructure, dynamically. Imagine that we want to reproduce all of this infrastructure, multiple times. We can scale up, at a moment's notice. All right, so this is where Ansible comes in. It helps us with configuration management, so we can manage each of these across cloud service providers. All right. So again, like I said, this is the DevOps end-to-end lifecycle, and so I'm going to. All right, I'm going to take some questions now. While I wait for questions, I'm going to go over to the previous slide and quickly tell us how, take us through how DevOps helps to make, how Azure DevOps has helped to make all of this very easy. Yeah, so yes, exactly. So this is where Azure DevOps makes all of this easy, right? Azure DevOps, can you still see my screen? Hold on. All right. So yes, this is where Azure DevOps comes into play. So Azure DevOps is in itself a powerful tool. So Terraform also helps with if Terraform helps with infrastructure management. So in the sense that Terraform is infrastructure as a code. So with Terraform, quite similar to Ansible, but the major difference between the major advantage is that Ansible also helps with configuration management, right? Terraform also does this IaaC, right? Infrastructure as a code. So there are so in DevOps world, there are so many tools that can help us achieve our goal of continuous integration and development. As you can see on my screen, Chef is a similar tool that helps with to manage configuration as well. Puppet, and there are so many similar tools. However, understanding the underlying principle and the function of each tool will help you to decide and choose which tool you require to achieve your organizational objectives and your goal, your company goals, right? So I'm just going to go ahead and so now this is Azure DevOps brings together all of this IaaC, infrastructure as code, infrastructure as code. So Azure DevOps with its offerings helps us to achieve all of this as well. So Azure DevOps helps us to achieve all of this as well. This is where Azure DevOps brings all of this technology together in a single software as a service platform. So there are so many alternative tools. However, Azure DevOps brings all of these tools in a single platform for us to take advantage of. All right. And so I'm going to take the next few minutes to quickly go over Azure DevOps and how it helps us by bringing all of this together. So again, if you notice that we have gone through, as you can see, we've gone through a bunch of tools, a number of tools, and it might get a little bit cloudy, right? Keeping track with each of these tools, right? But then Azure DevOps comes into play to help us manage each of these functions within our pipeline, right? And at this time, uh, Azure DevOps is one of the ways we can manage all of these processes put together. So basically, uh, uh, what Azure DevOps does is it brings all of this, combines all of these concepts and tools together, and everything that we need to release applications fast in an automated way and with high quality, as the highest quality possible. So for every project that you need to implement DevOps practices in order to achieve an efficient workflow, basically Azure DevOps would bring all of this together and help with the technological implementation of each of these process. All right, it's going to cover the entire, Azure DevOps covers the entire software development lifecycle from end to end. And the Azure DevOps platform has features that just makes our life so much easier. It's a very awesome platform and makes our whole life, makes life easy for every DevOps engineer. So with the Azure DevOps, we have the Azure DevOps, Azure boards, we have the Azure repos, the pipeline, Azure test, and Azure artifacts. All right, these are what Azure DevOps offer. And with the Azure boards, basically, like I said, we begin our software development lifecycle not by writing code, but by planning. All right, to begin our software development lifecycle by planning, and by planning for the actual functionalities and features that needs to go into our application. So before any code or any feature is written, before the code is written, first we must first plan, and this plan is usually done in collaboration with a product manager or a project manager as well, that will document this high level requirement and document the steps that are required uh, to for the features that document the features that are required to go into the application that we are developing. So we have something called an Azure board for this. We have something called an Azure board. All right. So basically, all of that end-to-end pipeline is found in Azure DevOps. And as you can see right here, we have it begins with the Azure board right here in the center where we plan, and after we plan with the Azure boards, we have the Azure repos which serves as a source code manager, where we manage our source code and versioning. Azure repo is also integrated. It works with Git as well. I think Microsoft Azure also owns GitLab. So GitLab basically is Azure repos, and here we can manage our source code and collaborate in real time. All right. So next, we can also use the Azure pipeline for build and integration. You can use Azure pipeline for build, integration, and testing as well. Use the Azure pipeline for build, integration, and testing, as well as release and deployment. So we can configure the Azure pipeline with some of the tools I mentioned earlier for our build, test, and build and release and deployment phase as well. So basically, build and release is when we create the artifact, right? So the process of building the software and creating the artifact is called build and release. So that's build and release. So when we build, release, and deploy, all of this can be done with Azure pipeline, as well as the operation and monitoring as well. Also, we can test with Azure. All of this is built into Azure. So I'm just going to take this one after the other. So we have the Azure boards, the Azure repos, Azure pipelines, the Azure test plans, and Azure artifacts. So it's an end-to-end solution. Organizations looking for an enterprise grade, tool chain. All right, so it's fully integrated with end-to-end traceability. We can monitor, track, track our planning. We can scale the project easily. We can collaborate in real time. Teams can collaborate. DevOps, developers, backend software engineers, quality testing, our testing team, QA teams can test in real time and collaborate in real time. Also, it is highly available, multi-region, on-prem and hybrid clouds. It supports hybrid cloud as well, meaning that with Azure DevOps, we can also work with other cloud service providers as well. And another key thing is that Azure, important feature is that Azure DevOps also provides support, right? You can get customer support on Azure DevOps. So it is a software as a service platform. And this is very, very useful at times where you might need to speak to somebody or reach out for support. You can get support via Azure DevOps customer support as well. All right. So again, there are there's six base main parts of Azure DevOps. Right. We have the Azure boards. Right. This helps us. This is where we plan. We plan the project. Here we track the tickets that are being created, and we assign tasks to team members that have different roles within the team, right? We plan and we assign tasks, right? Team members can go on their job boards. It's more like a Jira board, right? Where we track the tickets and see what is pending jobs, see what jobs are pending, see what jobs are priority jobs, and then we can tick off these tickets and mark as done or in progress. That's what we do with Azure boards. We plan basically and break down the plans into specific tasks that for each team member. In the Azure pipeline, like I said, we build, test, deploy with CI/CD, and it works with every language, with any language, and multiple cloud platforms and service providers. Work with multiple platforms and multiple cloud providers. Connect with GitHub and most of the tools that I mentioned earlier. Also, Azure repos, and basically this is GitLab, you know, in disguise, right? Azure repos is GitLab in disguise. Here we can collaborate in real time. And with Azure Test, we can test with confidence and ship our software after testing. Also, we have Azure Artifacts, and another important thing is the extensions that Azure DevOps comes with. Azure DevOps platform comes with extensions that gives us extensive features in the dev space. Okay, so this is a breakdown of how the Azure dev cycle looks, so we can see the Azure pipelines. Basically, uh, it's power packed, it's feature packed, the feature packed end-to-end platform. We can plan, develop, integrate, and build, package, test, release, monitor, configure, and then operate in real time. Right? All of this can be integrated. All these components can be integrated into Azure. So these are the Azure DevOps components that we have. All right. This is okay. So again, the Azure DevOps organization collection looks something like this, right? You have a project, and then for each project, you have the teams working, different teams. You could have a front end and back end team, different teams working on each project. And you can also feature multiple projects on the Azure DevOps platform. That is, so basically, we have our organization, we have a project, and within our project, we can have multiple pipelines as well. Like I said, based on your branching strategy, where developers are required to commit codes to the dev branch and then before it is pulled, for creating a pull request that pulls this code into a testing branch, and we would also have a production branch. So we can have all right, all right. So we can have multiple. Just let me know if you can still see my screen.
Yes, your screen is visible.
All right. Okay. So again, Azure DevOps basically comes with all of this functionality packed in. comes up with all of this packages, right? So with Azure boards, we plan, and then we can manage source code and collaborate with Azure repos, and so all of this is packed in, right? We can integrate every tool I mentioned into the DevOps lifecycle using Azure DevOps and manage development lifecycle from a single platform in real time. Azure Artifact also lets us serves as a factory, as a repo that lets us back up our artifacts. So helps us, we can back up our artifacts and in real time manages artifacts in real time. All right. Sorry, a minute. All right. And finally, with Azure Test, we can test as always, which is best practices. We can test. We can test in real time, and so yeah, I'm going to take the next few minutes to entertain questions and feedback. I'm sure we have a lot of questions. So, again, one thing to mention is initially, Azure DevOps is a paid service. So, as compared to the other tools I mentioned, which are mostly open source, and as a FinOps practitioner, I'm big on open source. However, you can, based on the organizational requirement and what stage the organization currently is, you can work with your budget and choose which best works for you as well. So now I'm going to take questions for the next few minutes. So if you have any questions, please drop them in the comments and I'll take them one after the other.
Okay, thank you so much, Larry, for this session. It was quite insightful. I'm sure that there was a lot to learn, and I'm sure that people, well, there's some questions that was already asked, and I think you've responded to most of them. But if so I don't know if you already attended to this question. What's the difference between DevOps engineer and SRE, like a site reliability engineer?
Sorry. Okay. So I think I responded to that. Let me see. So
Oh, okay.
did I respond to that? Yeah. I'm just going to go over it again. So basically, the primary focus is that DevOps in itself, like I said, it's a cultural, an organizational approach that emphasizes collaboration and communication between development teams. Right. So DevOps aims to uh, ensure collaboration between the development teams, operation teams. It's basically a series of practices, principles that you follow to deliver software in a reliable and consistent manner. So this is what DevOps entails. All right, but software reliability engineering is a much more broader term than DevOps. So for software reliability engineering, basically what this entails is you are ensuring reliability, availability, and high performance of production system and services. So you have services, software in real time, and then you're managing these softwares to ensure that there's high availability and reliability. There's no downtime. So basically, software reliability engineering encompasses DevOps principles as well, but the main focus is that software reliability engineers are responsible for ensuring the reliability of systems. They're responsible for monitoring and ensuring that there's zero downtime and there's quick response to incidents, right? So if there's downtime, the reliability engineer is a person that is responsible and to ensure that the systems are back up and basically to ensure there's zero downtime. So that is
Okay,
what software reliability engineering is all about. Just
all
to go
right.
right, I saw a question about platform engineering as well. So when you speak about platform engineer, a platform engineer is basically someone that has experience with different platforms. So by platforms, this basically refers to the different operating systems that we have. So we have Linux platform, we have Windows platform, we have a Mac platform, Solaris, and so on, right? So that's what platform refers to. So a platform engineer is somebody. So you could have a Linux platform, a Windows platform engineer, right? So that's what platform
Uh,
engineer is all
all
about.
right.
And then I've
Thank
heard
you,
that
Larry.
I've seen something about build and release. So basically, build and release is the process of building the software and building the executable file up to the point where you build the executable file and then you ship it at the factory. That's the build and release process, basically. You're welcome.
All right. Thank you so much for taking your time to answer the questions. And I want to say, everyone, thank you. I hope you enjoyed the session with Larry. I think you can reach him on LinkedIn if you have more questions for him or you want to learn more. His name is Ilerioluwa Arulu, as you can see on the screen. Thank you, everyone, for joining the session today. I hope it had been insightful. And thank you, Larry, for sharing your wealth of knowledge with us. So that brings us to the end of today's session, and we look forward to seeing you next week. Bye, everyone. And I hope you make use of DevOps principles and DevOps tools going forward. Thank you and bye.